Bismillah ar-Rahman ar-Rahim. Welcome back to our course, Deep Learning for Computer Vision. Today we'll tackle the lecture number 16. And fortunately, this lecture will be practical implementation of the neural networks, and it will be done using MATLAB. We are going to discuss some MATLAB functions, how we can use MATLAB for neural network applications, and we can solve many examples very easily using neural networks in MATLAB toolbox. So let's jump to the lecture and open our MATLAB session for our today's lecture. So if you open MATLAB, you will see the MATLAB homepage or the main command line as you see on the screen. Now, if you go to our lecture 16 tutorial that is sent to you on the MS Teams and on the e-learning system of the university, you will find a PDF file with this title, which is lecture 16 MATLAB tutorial on neural networks. So you see here that this is a MATLAB tool for computer vision and specifically for neural networks, shortly ANNs. You can see that in MATLAB you'll find a toolbox, which is a very strong toolbox for neural network design and implementation using MATLAB. Of course, here you can go directly to the toolbox by clicking directly the command line, as you see here, net, or you can ask for some help or on net. However, let's follow this tutorial and follow the instructions in the tutorial in order to make things easy and smooth. You can find also help using demos, as you see here on the screen. This one. Okay. So let's start with brainstorming. Here you can start also by clicking or writing a command and start on the command line in MATLAB. So if you go to MATLAB, you can write and start and click on on enter, and this will give you it will open a window of as a starting step for the MATLAB the demo on neural networks. However, let's skip this to the next part of this lecture. Here you can find many applications like output fitting, pattern recognition, clustering, and linear series prediction and modeling, and other tools also can be available in MATLAB. Let's start with a simple thing. Of course, I'll skip this for the next part of our lecture. Okay, and I'll go directly to the command line functions, the basic functions in the toolbox. Mainly, if you want to design or to build a neural network, you have to pass or to do this in a workflow having the following steps. Step one, you need first, before starting with MATLAB, you need to collect data. So you need to have a data set that is required to be used for training and next for validation and testing. Next, you need to create your own neural network. So you need to select a proper network for your applications. You can test many or different neural networks with different, let's say, number of neurons and number of hidden layers. All these things are to be described in details. Next, you can pick to initialize the base and the weights and the biases. If you use feedback propagation, you do not need to initialize these values. Otherwise, you have to do this as an important step. Next, what we can do, we now have the network, we have the input data. we need to apply training. So we train our network and see what's going on. After the training step, you can go to apply testing. So you can validate the network to apply the validation data. The testing data, we usually, when we collect the data and we have a data set, we split this data set into three parts. The main part having up to 70, maybe 75%, maybe more or less up to 80, from between 60 and 80, that will be used for training. While the other two parts, the validation data set and or subset, and the testing data subset, where the validation will be used during the training to follow and to control the main operation or the main functions in the neural network, and this will take about from 10 to 15% of the data set. And finally, for the testing data, you can use extra data from outside the training set, or maybe you from the beginning you split apart, or you take a part of the input data set and use it as a testing data set in order to test your system. And in this case, this data for the testing data set was not used before during the testing, during the training, while the validation data set will be used during the training for validating the neural network itself. Finally, if things are okay, you can publish or say that this neural network is okay and it's working well, and it can be used for other purposes and for your own applications. If we start with the general commands in the MATLAB neural network toolbox, we find the command network. It's a very general command. As you see here, the syntax, you can it's clear that the command is net in network, will assign a variable net to network. And here, if you press on network, you can find all these input variables in the network. Firstly, you have the number of inputs, number of layers, the bias connect, the input connect, layer connect, and output connect. All these parameters can be found in the description of the help. If you go to the network in MATLAB, you will find this by pressing help network, as you see here. However, let's start with finding this help. Let's go and press help network, and you go to the documentation. It's better if you can also read from here. I usually go with all details here. I usually go to the documentation for the network, and I have already opened this tutorial here. So this is the this is what, if you press on the MATLAB command line here, documentation for network, it will open this page, or let's say window, and it will repeat the same thing as was given in the MATLAB here, but in a present view instead of having this in this way. So let's go here and see. It gives you the information about the function network. As you see here, network. Okay, here you can find the number of inputs, number of layers, number of bias connect, input connect, layer connect, etc. All these parameters can be defined during the call for the function network. You can see the properties with details on every one of these things here. And you can see the function properties, the parameter properties, weights, and base properties, etc. So let's go back to our tutorial. In this case, we have already seen these things. Here we have the number of inputs. The default number is 0. Number of layers default is 0, etc. We can go and span all these parameters regarding the network command line or the network design. Now we can go to we have the network is a structured function or variable, so we can have sub objects of the structure like net inputs. Here it's an you can when you call net dot inputs, you can define or see what is the number of inputs in this system, number of layers, number of bases. The same thing is valid for the function used for initialization, for the weights, for the outputs, etc. And you can call also the net.iw. This will give you number of layers by number of inputs in the cell, and the same thing for the net b. For the biases, it will give you a numbers. Let's say number of layers was 10 by one cell array that having the bias values for number of LW. This will give you a number of layers multiplied by, let's say we have 10 layers, so you get 10 by 10 cell array or matrix having the weight values in these cell locations. So let's have an example here. Let's start with this example. Let's define a variable net, which is you call network, and you define now net number of inputs 1 and number of layers is 2. So let's copy this to the command line and run. So you get some sort of this gives you what's okay. It's CLC to clear all these again here. So this will define for you a network. Sorry, neural network with the name, custom name. Okay, this is the dimension. These are the details regarding this network, the connections, the sub-objects, functions. All these things can be found in this net defined layers. Okay. Now let's define the number of layers. The same thing as we have done here. We can repeat the same steps. So instead of having all the 3 lines before, we can just only write, sorry. You can just click on this this command. So we have here 1 layer input and 2 layered network, and we'll get the same thing for the parameters and objects and sub-objects of this network as was described in the 3 lines code before. Okay. We're going to fitnet. If we try, let's say we want to depict our network, we can use the command view net here. So this is our network. Okay. For me, at least as a starting point, I can see that this network is not clear. Absolutely, there's no connections. So this is the input. Okay, this is the input. This is the first layer, second layer, but with no connections in between. So this is just for demo applications. And so what to do now? How to get a connected layer? We need to go back to the definition of the function network as before here, to this function, and try to provide all these details. Now, in order to help you doing that, let's remove this one. We can go to MATLAB help, as we have seen before, and here we have some examples. For example, in this case, this is a network using 2 layers. one input two-layered system or network having these parameters. If you look here, you can see that number of layers is 2 layers. We have 2 bases. We already give that the first layer has a base, an input, as you see here, that these details are given according to the parameters selected in here in this command line. So let's copy this one, copy and Control C, copy. We can just directly apply right click, evaluate selection. So we evaluate this selection on the MATLAB command line and we get these details regarding this network. Okay. Now let's view this network. Okay, we have already a 2-layer network with one input. Okay. And then see here we have the input layer with weights and bases. The second layer having only the weights with bases that are with a base that is equal to 0. And we go further with the activation function here. It's a linear activation function, the same thing for the output. And this is our simple neural network. Let's modify this by having, let's say 4-layered network. We click here. This is an error because we need to describe for these layers these parameters, all these parameters for the 4-layered network. Okay, so we need now to define and add parameters for the 4 layers in this network. Let's go now and check for the fitnet, the part or the type of functions. The fitnet, it's a neural network that can be used for fitting applications. It's already built in MATLAB, and you can just use it and apply the parameters required to run this function. The syntax is fitnet. You have to define firstly the number or the hidden size. Now fitnet, you can also apply the hidden sizes and the train functions. So when you apply neural networking, you need to describe the network by itself. Here you just need to apply or to define the number of hidden layers and the hidden size of the layers. Now you can also define the train function used in this case. You can select this from a list of applications. By default, there is one type of training function, which is if you do not describe the train function here, you will take the default value for the train function, as will be seen below. Here, let's see what are the train functions that are required. The default is train LM. Train LM is a short description or abbreviation for Levenberg Marquardt technique or algorithm. You can now go to let's remove this one. You can go to YouTube and ask for this technique. What is Levenberg Marquardt technique or algorithm, and you can find out of functions or out of videos regarding this issue. You can see this one because it is based on MATLAB and describes in details how this algorithm works. For us, it's a very familiar and very well and smart technique that can be used in deep neural network optimization. And we have another list or other training algorithms for optimization, like the Bayesian regularization, BFGS quasi-Newton, etc. We can find also here the gradient descent with momentum discussed in the last lecture, and we can find here also the gradient descent standing alone, and we can find also variable rate gradient descent. All these techniques are valid and built in MATLAB for your convenience. Here for the hidden size, we can use the default value, which is 10. And now you can specify a network having, for example, 3 hidden layers. You can change the number of hidden layers. You can change the number of neurons in every hidden layer. So in this case, we have 10, 8, and 5. For example, I'm talking about this example. You can apply this by having by varying or by changing the number of neurons in every hidden layer. Let's start with this code. So if you want, I can give you a simple example on having the fitnet function. Let's try this one. Net is equal to fitnet with the functions or input parameters 8 and maybe 3. We'll try to do and see what will happen. View this network. Oh, sorry, not view only. Yes, view net. So you can see here that we have a 3-layered network having 3 hidden layers, hidden layer 1, 2, 3, and the output layer as you see here. Okay, and here we have the biases are given in according to for the first hidden layer we have and for the first one and second, third, all hidden layers having weights and biases, and the last, as you see, the output in the layer here, if we can zoom this one, yes, okay. The last layer, it has an identity or linear activation function, while the other layers are having a sigmoid or I think it's a tan H activation function. Of course, you can change this. We'll see later how we can modify all these things. Let's go now down and see an example on in this example, we need to firstly collect data. In MATLAB, you have some hidden or stored data sets that can be used. For example, here we have something like simple fit data set. This is you can just load it because it is given on the path of the MATLAB folder, and you just need to pick this data. So you can now load this data into MATLAB. It is stored somewhere in the folder in MATLAB, and we just now need to load this data by having the x and y values. As see here, we have x variable and y variable and t variable. If you look at the bottom right corner, left corner, we have x and t. If you click on x, you can read the data in the, as here, it's a vector or a row extending up to, it contains 94 samples. Okay, and t is the time. However, we can now view this data by plotting, for example, plot x with t to see what about this data, and let's go here and Control V and click and see. So this is our data stored in the simple data set, simple fit data set in MATLAB. It's a sort of some curve, some data or signal, and we want now to see how this data can be tackled as a data set. So we have the parameter t, which is the time, and x is the amplitude in this case. Same thing as here. I want to use a neural network having 3 layers with 10 neurons, 8 neurons, and 4 neurons with, and want to create I want hidden or network using these 3 layers with the output layer and view this network. So let's copy this and go to the MATLAB command CLC Control V and click OK. What is there here? Okay, because we just need to remove this. This is the face command. Okay, VUnit. This is VUnit. Again, we have sort of neural network. As see here, we have the input layer. Okay, this is the input layer. And this is the first hidden layer with 10 neurons. We have second hidden layer with 8 neurons and so forth until we reach the last layer, the output layer, with as see here we have just to combine the weights and use the this is the fitnet. This is how the fitnet is designed. It has a linear activation function. Okay. We need now to train this network. We have a command train. You can ask for help. For example, let's go to the help here, and you can write directly at the top here. You can write at the top of that train. You see? So you can select one of these outputs. You can shallow network training, for example, this one, and you can see the syntax and how you can change the training. Here we have examples on how to train. You have a lot of details that can be run, and the MATLAB is very rich of examples and tutorials on the net and with supported with the software itself using this help documentation. And you can see these examples, and sometimes you can train and directly click here and select, for example, this part and right click to evaluate this part of the code and go and see sometimes the help on the selection, for example, printing F1 on the selection, they'll give you information about the plot function that is included here. However, we just need to go to pick the train function and use this command line. For sure, in this case, we are using the default training algorithm, which is the what we call it now, the Levenberg Marquardt technique or algorithm. And if you want to change it, you can use GSDM. You can use variable length GSD or GSDM. There's a lot of training functions that can be used for optimization in this issue. So let's click Control V. Of course, here we have a small data size, and the training will be very quick. It will be running very quickly, and will not be able to control or to see and visualize the training stage very slowly or in a proper way. However, if you click now, this will open for you a window for training. So this is the result of the training. So as you see here, we have a default number of in this fitnet of 1,000 steps, or we call it epochs. Okay, it's almost done now. Of course, these details here, we have the number of epochs. We stopped at the value 147 because we reached a specific error rate or learning rate. In this case, it will be for us something like maybe point oh oh something, point oh, as you see here, 0.01, maybe 0.1 to the power e minus 10 to the power minus 5. Now the validation check, as you see here, we stopped value at 6 validation checks points, and below we can see here at the lower part, if you follow this. Let's have a pen at this point. If you look at this part here, you can find some performance evaluation plots that you can, if you click on these, you'll get different things like the performance, the training state, the regression. We'll come back to this later on. It's an advanced step for this tutorial. This is our network. These are the parameters used for training. These are the training plots that can be seen. Now we want to check, after training the network, we want to check a specific value, which is x, without having the value t. And we just need to apply, we want to use this network. Because as described in here, the performance of the network is very well acting, because the performance, we get an error rate approaching 0, 0.00102. It's the mean square error. It's a very small value. It started at a value of 19.3, which is very high. And the gradient also in the gradient in this case, it was about 47, and it was going down to 0.0127, which is a very small value, and this means that the network is already trained. This depends on you and your topic or your selected parameters regarding the training parameters or the parameters used to get your final result for your network. So here we need to, we already trained the network. Now we need to check to give an input x and find the value for y. And this is for y. If you click here y, it will be something like this one. If we look here at these are the values for y, you just now need to check the error between the y values and x values and see what will be the output or the error in this situation. So we can now, using this function, we can also perform, use the command line perform to perform testing on the data y extracted from the network net using the input data x. So you need just to perform and to get some parameters, some output results. So in this case, the error, the average error for all values in y in respect to the input x and having the variable, the time variable t, is 1.35, almost 1.35 by 10 times minus 5, which is a very small error, and it's very highly accepted, and is going that as a good result. We sometimes can also add this just for quick check, plot between the change the values and plot the error. Now, if you look at the error, you'll see something like figure. So open a figure, then plot the error. the error will be very small, as you see here. You have at many places different values. However, you may find some peaks here, but in general, the value will be less than 0.025. As an average, it will be very, very small value with an average value around the maybe one of the thousand or maybe less also. Okay. Now let's go and see our network and look at the what we can plot there. Let's close some of these functions. Close this one. Close this one. Let's go now and see. This was the training of our network. And we can go to see the performance and the all these details. And let's go back now to the first part of our tutorial where we can see all these things in details. If you go now, as we started to depict or to plot or to, let's say, type and start, we get, let's, window like this one. It is a window that opens for you. You can also see other commands like here with these links. Now, let's have a sort of fitting function or regression. Let's click on fitting application in MATLAB. We can go now to the, of course, I have already prepared these in before. Let's see. Now you can import your data to train the network. Of course, for the network for training, in this case, you select for fitting two-layer network with the hidden layer having 10. And now you can modify this. You can modify this by changing these parameters when you apply the code. Let's now import, let's say, what we call a simple fitting dataset. You can import another dataset which is called Avalon rings dataset and body fat dataset. However, you can load your own dataset, and you may have other examples like building energy dataset, chemical dataset, engine dataset. Here you can find all these things, and you can import your own data set. Let's start with the simple case, with the simplest case. Okay, this will clean all these things. Okay. Now, if you look at, let's wait for a while. Okay. Here we cleaned all previous data. Now we want to try. We want to change the parameters in this network. For the fitting network, the structure of the network is always the same. You can modify at least for graphical presentation here in MATLAB. Now you can change the ratio. Let's zoom this one here. The training data, it can be assigned for 70%. You can change the validation data to make it, for example, let's say having this as you can select to be, for example, escape 14, 10%. You can select also for that this data set maybe 10 and leave most of the input for training, which is 80%, and you can keep it as it was there, 15 and 15. Let's keep it as is. Now you also can modify the size, layer size. Can change, for example, to make this 14 or 15. If you look here, you can see the changes that you have done to this hidden layer. You see here we have 16. If you change it to, let's say, 10, you'll get again 10. So our system is already maximize. Don't maximize this one. Okay. Okay. Now we try to train. During training, we can apply the training step. Here we have a lot of epochs. We finished with 186 epochs as it was mentioned in the previous example. Here we have, this is the number of epochs. And now we can see what is going on in this network. We can also test this network. As you see here, we can test the network. If you apply the test, it requires that you want to test data from outside the training set. Okay, so you need to browse and to go and select from your own computer where is the input that you want to apply for testing. Okay. However, we don't want to do this. Let's go back, cancel. Let's go back to our network and see what happened there. And want now, for example, to see the training state. Let's go and see the training state. It gives you information about the training performance during training. So you see that the gradient, the error will be at epoch number 186. It was about 0.00 something, very small value. Now for the mu value, it was e to the power minus 7 at epoch 18. As you see here that somewhere where the epoch, after having this epoch passing 186, it tries to some higher value, while at this location it's was very small. Also here we have very small value at epoch 160, etc. The same thing we can here check having these points, just going close to the line, and you'll get a depict of the x and y values. Now for the validation check, you see at epoch 186 we have a 0 value for error, and this is after that the value of the error is increased. It comes to 5 to maybe higher values. So we stopped at the epoch 186 because after that extra epochs may not lead to best performance. Let's go now to the performance and see what we mean by the performance. Here we see as you see in this curve, we have mainly 3 curves. The blue curve for the training, okay. This one is for training, blue color. The second one, validation for this one, this green for validation. And third one for the red for testing data. We already split the data into 3 parts, training, validation, and testing. As you see that, while the epochs are going further, while we repeat in iterations or epochs the process until we reach a minimum somewhere at 186, and it's clear that the error by time or by iteration is going down and down until it reached a specific value. This gives us information about the performance of the system or this neural network. Now, if you go to the regression, performance, and see what is the input data, the training data, and the tested after applying the training, what happened to the curves. Here we will talk about this in future lectures. However, here we have different curves for the output in the error. Now we have, this is for the target this is the fit curve, the line, and this is the circles having the data for the R when it is equal to 1, as you see here for the target, the R value must be somewhere defined here. The output is around with a small error with 1.5 to the power minus 5. Here for the training data, here for the validation data. Let's pick a pen. So this is for training, this is for validation, and this is for testing, and this is the overall with all curves together. And as you see that the fitting is almost straight line because the data is very simple and can be fitted easily, and the error is very small in this situation. In other problems, it may be a little bit more difficult to get some such results. Sorry. Let's now see the fit between the input and the output, or between the data before and after training. So as you see here in you go to the legend here, you see that the dots, small dots, are training targets, plus with red color, with the blue color is the training outputs, etc. And what I'm interested with is the errors and the fit. The gray color is the almost, or the blue one is for the fit. You see the data for all cases is with a high fit. Can see the fit is high, and you can here see the errors. Somewhere we have some errors between the fitted data and the trained data at the input. So our target and the output. And as you see that the fitting task has been done perfectly with high performance. This is one of the good functions that can be implemented in neural networks. Of course, we can increase and modify the size of the network. And now we can furthermore, if you look here, export plot to figure. If you are interested with having this figure, you can just export, click on export plot to figure, and it will be exported outside MATLAB to figure, and you can just save as, either as, you can save it as maybe .fig for MATLAB, or you can change the type of the figure and save it as, let's say, JPEG, etc. For example, JPEG, and define where you want to what folder to save in. Okay, this is for the figures. Now, another thing, let's remove this one. You can generate or export the model. Now you can export the model to the workspace, so you can just the result of, or the trained network, we call it net. We can export it to the network and to the network to the workspace. For example, if we click here, clear, we clear the network that is already here in. We need to export this network. Where is this one? I think it's okay somewhere. Just a moment. Okay. Where's our network? Let's remove all these things here. No, this one, title, neural network. I think I have already cleared the network. Anyway, import again, we'll repeat, not this one. Again, we'll repeat this fitting. Okay, this one. Okay. Now, you can export this model to the network, okay, to workspace. I have exported to workspace. I removed, we'll call it, for example, as net1. Let's see if we have, okay. We'll see that when we go here, we'll find net1 here, as you see here. Double click on this or clicking, you can find the network, and you can find also the training results obtained in here. You can click on all these performances to see what are all these results that were done using the graphical user interface for NetFit. Okay, what else? I think you can also export the code. You can also export the function for MATLAB for compilation. You can export to Simulink for sure, but here you can export for MATLAB compilation. And as here, we have a function that can be used with all details regarding this network. Here you can modify, you can change your parameters, you can change the number of layers and apply run to this network. I have also saved it in a script file. Here it's a script without, it's not a function, it's just a script that can be also done using MATLAB, the graphical user interface of the network. And this can be performed here. You can change, for example, training function here. Instead of having train LM, you can use train gradient descent. You can change the train function. You can change the hidden layer size. Here we can change this one. You can change also the steps, the division of the how many percent you want for the training, for the validation. You can do this on a code basis, not on a graphical user interface basis. Can change the error instead of MSE. You can change other type of the network performance function. You can here pick this one and change it to absolute error or to other types of errors, etc. All these things can be done on the code level and can be obtained easily. Let's go back to our tutorial as an start tutorial. You can do, let's say, pattern recognition. If you click here on this command, I have already opened this file. This is the network. You can import data. Again, you can use for pattern recognition. Let's say import simple data classification. You can import cancer dataset, glass dataset, other datasets like iris flowers, thyroid data, wine data. All these data are available in MATLAB. You can apply by your own and construct your own dataset for power communication, for computer applications, etc. You can repeat the process. In this type, you are going to apply classification. Let's zoom for, let's enter the cancer dataset. Okay, we'll clear all. Okay. And let's see our network. Again, it's two-layered with hidden layers, two hidden layers, or one hidden layer and an output layer. Now let's go to the training. We can modify the number of layers and apply train. The training stop at 24 epoch because we reached a very small value of errors and gradient, as you see here, and we can stop. Now we can repeat the same application training state, for example, performance. Here we can see the at the top here, as you see here. You see the confusion matrix, the ROC curve. This will be discussed in details on the next lectures. So we'll keep it for next lectures. However, for the state, you can see that the gradient is going down with a number of epochs with iterations, and the error validation of the validation is some little bit fluctuating, and after it is going up, and it reaches a high value for the 24th epoch. However, the gradient has reached a very small value. So you need now to decide whether to continue or to stop, or to go back to the 20. For example, we have zeros here somewhere. We may stop at, for example, at this layer, this epoch or iteration, and stop at that point. I think it's okay for today. The topic is not straightforward. However, you can follow the instructions in this command, in this file, and in MATLAB you can go to YouTube and check for other applications. Just one thing left. You can also in MATLAB go to apps, as here we have apps at the upper left corner. If you click on the apps and go to the scroll bar here, you can find machine learning and deep learning applications. You have classification learner, you have a deep neural network designer, you have deep network quantizer, you have experiment manager, you have also neural net clustering, neural net fitting, neural net pattern recognition, time series, regression, reinforcement design learning. All these things can be found and can be applied for different neural network applications. And we'll step by step will explore all these topics. And today we have a quick view on neural network clustering and neural network fitting. Maybe you can try neural network pattern recognition and neural network time series for nonlinear operations. And I hope that it will be useful for you and enjoyable. Little bit it will be not easy as a start, but after a while you will feel that you are going better and better, and you will be a master regarding this issue. Thank you for your listening, and hope that you enjoyed this lecture and tutorial, and hope seeing you soon on next lecture, inshallah.